Hi, in this video we're going to talk about a database option called page verify. Now page verify, as its name suggests, verifies if the information in a page is correct. Now the reason why we have this option is because the database, as you know, needs to store the data exactly as you inserted it. However, there are other aspects to the hardware, such as the hard disk, which might often get corrupted because of wear and tear on the movable parts, issues with the firmware, etc. And as a result, we want to be able to verify if the data that we're getting back when we read is exactly the same as the data that we inserted in the first place. In order to do this, every page gets written with some kind of metadata, which is either a checksum or some kind of tone page bit value, to help identify if this page has been modified in any way since we have inserted it. One way to understand this would be if you download files of the internet. You might have seen on certain websites they indicate the MD5 or the checksum value or the hash value for that particular file. By comparing the file after you've downloaded it with the checksum value that was provided on the internet, you'll know if the page has been corrupted or the file has been corrupted in any way. And that's kind of the same principle that gets applied with database page verify as well. Now, if you look at the database, what you will basically see is if you right click the database and go to properties, under properties you have options, and under options, if you scroll further down, you'll have an option called page verify. The default is checksum, which is kind of the industry standard, and really the other option shouldn't even be available in my opinion, because they were meant mainly for backward compatibility way back when in SQL 2000. Now you have none, in which case basically what happens is there is no kind of page verification happening. Now the important thing to understand here is that page verify doesn't prevent corruption from happening. It just helps you identify if something has been corrupted since the last time you fetched it. So by choosing none, all you're basically saying is I don't care if the page is corrupted, just fetch whatever is available. And in tone page detection, what happens is for every 512 bytes, 2 bits of information gets added to the last header, to the last bit, and then that gets added to the header. This doesn't really give us as thorough a protection as checksum, because again, in checksum what happens is we're reading the entire page, all 8 kilobytes of it, and then creating the checksum. So a lot more information gets validated within the checksum. Now there are a lot of internet articles about tone page detection being less CPU intensive, but the fact is I've not been able to see that behavior, and I think because of that it's fairly minimal. So in the interest of getting the maximum value for the option, the default should always be checksum. And that's the standard, basically. That's kind of the default, so you don't really need to worry about it. It's supposed to be what you're supposed to be using. Now to understand this, what I'm going to do is I'm going to cause a corruption in a data page just to show you how the option works. So let's leave it at the default checksum for the time being, and I'm going to drop the database, and I'm going to create it again and create a table, and in the table I'm going to insert a value called Jayanth. Right. Next, I'm going to detach the database, and a very helpful tool I found on the internet is hex edit with a I in dot before the I. Now I'm going to pick up my file, and I'm going to search for my name, and you'll see that it's found one row. And when I click on it, you can see inside this I've got char, so there are a lot of spaces, and then I've got J. So I'm going to change the capital J to a small letter J and export this. So that's pretty much all I've done. I've just changed one value, but as you can see, it was done outside of SQL Server. So the checksum and all the other database aspects of it still continue as if it was when I inserted this data using the script. So now that this is done, what I'm going to do is I'm going to attach this data back, or this database back. And you'll see that I inserted it with a capital J. And I'm going to use tone page detection here. And to confirm that, I'm going to run page verify option description on the sys databases for the ID 9, which is the ID of the database. And now when I do select star from my data, what's going to happen is SQL Server is going to try and read the data, and as soon as it does that, it's going to identify that something isn't right, the numbers don't add up, and you'll get the error message here. As you can see here, message number 824, SQL Server has detected an error, and that tells you that the page has been corrupted in some way. And the same thing happens if you change the database to checksum as well, except for the error message is a slightly different one, but it's able to detect the corruption. That's kind of the main point here as far as how page verify works. So let's see what happens if I change it to none. As you can see here, when I change it to none, SQL Server doesn't really care whether the page was changed outside or within SQL Server, and as long as it's able to read the data, you're going to get some output. So that's kind of what page verify does for you. And if you run DBCC CHECKDB, which is kind of what we use to check whether SQL Server has corrupted any pages or whether any pages have been corrupted, you'll see that when it's none, you don't really get any consistency errors. The next thing we want to do is let's go ahead and just change this back to tone page detection. And now what you'll see is it doesn't care. So once you go to none, what happens is it doesn't really bother about whether the page is corrupted or not. And that's kind of a disadvantage because the page actually is corrupted. But what happened is when we fetched the data, SQL Server understood what it was, and therefore now it doesn't really bother to verify if the page is corrupted or not. The other thing you want to do is, let me just go ahead and really do this one more time here. And I'll just show you what DBCC CHECKDB would do if we had done this the right way. And I'm going to search for the name again. Found it here. And I'm going to change this to a small j and export it again. Overwrite the previous file as before. And now I'm going to attach the database. And I'm going to choose, let's say, Checksum, which is the default that we're supposed to be using anyways. And you'll see that again, Checksum will identify that there is corruption. And if I run CHECKDB, you'll see that CHECKDB actually identifies that there is an issue, and it'll tell you the page number, etc. And what that basically means is the next step for you would be to go ahead, look in the backup, and try to do a page level restore of this particular page to remove the corruption. If you have database mirroring, naturally automatic page repair happens within database mirroring, so that can take care of the issue for you as well. But bottom line here is that if you have a database and if you're using page verify, the option is supposed to be checksum, and frankly speaking, doesn't really feel like that's an option. It's supposed to be mandatory, and it's just something that you're supposed to be checking in your databases anyway. Well, I hope you've enjoyed this video, and thank you for watching.